Right now, 250 miles above your head, a 1 million pound metal island is falling out of the sky at 5 miles per second, and it's been doing it for 25 years. But what's growing on the outside of it shouldn't even be alive. At 17,500 miles per hour, the International Space Station moves faster than a sniper bullet. It's the size of a football field, costs $150 billion, and experiences 16 sunrises every single day. But behind the pristine NASA footage lies a dark reality. Scientists are now quietly debating a terrifying biological mutation happening on the station's exterior. What you're about to hear changes everything. How long until this engineering marvel becomes our greatest threat? To understand the danger, you need to understand the machine. The ISS is the absolute crown jewel of human achievement. Built piece by 15 nations, it's a zero-gravity laboratory designed to test the limits of human endurance. We know exactly how it stays up there, perfectly balancing centrifugal force with Earth's gravity in a state of continuous, breathtaking freefall. It's a sterile, highly controlled environment. But this is where things get strange. Because the void of space isn't as empty as we thought. What I'm about to reveal next involves a classified level anomaly currently multiplying on the station's hull, and uncovering truths like this is exactly why thousands of people are joining our community every single day. Hit that follow button right now, because you do not want to miss what we're tracking next. The mystery began during what was supposed to be a routine spacewalk. In 2020, cosmonauts swabbing the outside of the ISS, in the freezing, heavily irradiated vacuum of space, found something completely impossible. Live bacteria. Fast forward to 2024, researchers at JPL analyzing samples from the station's internal filters isolated highly mutated strains of a bacteria called Enterobacter buchandensis. But the chilling part? It wasn't just surviving the deadly cosmic radiation. It was thriving. Here's the leading theory, and it is mind-bending. The ISS has inadvertently become an evolutionary pressure cooker. Think of it like a cosmic gym. Bacteria from Earth hitched a ride on cargo ships, and to survive the deadly radiation and zero-gravity environment, they rapidly mutated, literally building biological armor. Scientists around the world are now studying these extremophiles, calling them fundamentally distinct from anything on Earth. But if they're mutating this fast to survive the brutality of space, what happens if they hitch a ride back down to us? But here is where it gets crazy. Just when you thought mutant space bacteria was the biggest issue, a massive new threat has emerged. Structural fatigue. Unexplained microfractures are appearing in the Russian Zarya module. Some experts argue the ISS is simply aging, battered by thousands of micrometeorite strikes every year. Others believe the constant thermal shock, swinging 500 degrees Fahrenheit every 45 minutes, is literally tearing the metal apart at the molecular level. This leaves global space agencies with a massive dilemma, and I genuinely want to know what you think. We have two options. Do we spend billions to repair and extend the life of the ISS, risking a catastrophic structural failure in orbit, or bringing mutated pathogens home? Or do we deliberately crash this $150 billion masterpiece into the ocean to destroy the threat before it's too late? Drop your verdict in the comments right now. Seriously, let's debate this. Save it, or sink it. Stay with me here, because this affects how we see our entire place in the universe. The ISS isn't just a space station, it's our blueprint for surviving the cosmos. If our microbes can evolve into superorganisms in low Earth orbit in just a few decades, it fundamentally shifts the panspermia debate, the very real scientific theory that life on Earth may have originally come from space. Furthermore, if we can't keep a station intact for 30 years just 250 miles away, how do we plan to build permanent habitats on Mars? How do we survive generational ships to Alpha Centauri? What we learn from the ISS is final. Fracturing days will write the absolute rulebook for humanity's survival as an interplanetary species. But it's not all doom and gloom. Science adapts. The impending, inevitable retirement of the ISS is already sparking a new golden age of space infrastructure. Private companies are right now designing commercial space stations equipped with artificial gravity rings and self-healing smart materials. The ISS has bravely taken the hits so we could learn what we actually need to survive the dark. By the time it's finally guided down into the water, remote graveyard of Point Nemo in the Pacific Ocean sometime around 2030, we will already have the next generation of cosmic outposts waiting in the wings. We are learning. And humanity is moving forward. But the ISS isn't the only massive object hiding dark secrets in our solar system. What if I told you the James Webb Space Telescope just detected something impossibly massive moving through the Oort cloud? Or that Voyager 1 just started sending back telemetry data in a mathematical sequence we don't understand? Thank you for exploring the unknown with us today. As the ISS completes another 90-minute orbit around our beautiful planet, remember that our greatest achievements are often just stepping stones to even bigger mysteries. The universe is full of secrets, and we're just getting started. Stay curious, keep looking up.